In this video, you'll learn about how machine learning is used in computer vision. As humans, we see and identify objects every second of the day. It just happens. We don't even think about it. Computer vision is essentially a way that computers see and identify objects in pictures and videos. But how do computers see? On a basic level, computer vision is recognizing patterns. Vision algorithms need to recognize objects from different perspectives and in different environments. To do this effectively, many algorithms are created using machine learning, or ML, and are generated using neural networks, which is a subset of machine learning. These algorithms train a mathematical model for recognition, given potentially millions of example images. On a high level, image processing neural networks, also known as convolutional neural networks, are trained to look for patterns in local regions of an image and fire whenever a pattern is detected. Parameters for this pattern finding are trained from data. The pattern search happens compositionally. First, a base set of patterns is searched for in the original image. Then a second set of patterns processes the previous firings and so on. Earlier patterns are low-level. Think firing on lines and corners. It's not until many patterns are chained that high-level concepts, such as a human face, start to emerge. From here, the network's design will depend on the task at hand. The key takeaway is that the model builds up an understanding of content in the image. In this sense, the computer is able to see. So, how does training work? Well, many applications use ground truth data associated with each training image. The network takes a training image, computes predictions for that image, and then compares this output to the ground truth. The differences between the two give the network feedback on its prediction, which it uses to adjust its parameters. Machine learning algorithms are only as good as the data fed into them. Certain tasks may require a large amount of labeled data. For example, with semantic segmentation, large data sets have been manually labeled by people. Precise manual labeling isn't always required for training, but many implementations require it. For example, to make a computer understand how to recognize a dog, we could feed it thousands, even millions of pictures of dogs. An algorithm will allow the computer to look for patterns in all the images, such as the colors, shapes, everything about the images that will help identify what dog means. When it's finished, the computer can see a dog in any image. Any missing information or biases that are inherent to the datasets will impact the result. So, for example, if you feed the computer images of a cow along with the dog images, the algorithm to identify a dog will be flawed. It's always possible for an ML model to be wrong, but bias can result in it being consistently wrong on certain categories because of lower frequency of the examples in the training data. Bias can negatively impact the AR experience for certain categories of users. So the bottom line is, it's very important that ML models are trained to mitigate bias. Computer vision allows computers to identify and see the world, much like humans do. Algorithms enable this ability and act like the brain to help make meaning out of identifiable visual objects in pictures and videos.